Hello and welcome to this video. I am Karnesh Chauri and this video is about structures and unions in the C programming language. We start with the basic question: what is a structure? A structure is an ordered collection of variables of different types and sizes of an entity. We have seen arrays, which are ordered collection of multiple instances of the same variable. Here we have variables which are of different types. For example, the payroll record for an employee, it has employee name, address, date of birth, ID, etc. We can declare a structure employee like this: struct employee, char name, name size plus 1, char address, address size plus 1, char DOB 9, char ID, ID size plus 1. It is a structure tag, something like a type. A variable is not defined yet. We can define a variable of structure type employee by definition struct employee emp. Now a variable emp has been defined, which is a structure with a tag struct employee. After that, we can assign values to the members of variable emp and use the values of members. For example, use strcpy to copy a string into a member and use printf to print it. We can define the variable along with the structure tag, as in this example. The structure tag is struct point and the variable name is also point, and we can skip the structure tag and directly define the variable as in this example. There are 4 operations that are permitted on structures. First, structures with the same tag can be assigned to one another. Let's say we have 2 structures, emp1 and emp2, both with the same tag struct employee. The structure emp1 has some fields initialized. We can assign emp1 to emp2, and after that both emp1 and emp2 have identical values for all members. A structure can be passed as an argument to a function. Also, a structure can be return type of a function, and structures can be initialized at the time of definition. We can put an equal to sign and enclose initialization values in braces. Pointers to structures. The ampersand operator gives the address of a variable which can be assigned to a pointer of that type. This of course applies to structures as well, and there is a special operator, a minus sign followed by the greater than sign, by which you can access the members of structures from the pointer. For example, struct employee emp star ptr. Emp is struct with the tag struct employee, and ptr points to a structure of the same type. Then we can assign ptr with the address of emp. Now we can access members of emp structure using this member access operator. In the good old days, we used to have a lot of arrays. Suppose you want to store data about students in a class. The students have numeric roll number in the class, which used to serve as array index. That is, array index would be roll number minus 1. Now you have arrays of student names, array of student IDs, and arrays of marks obtained in economics, and so on. All this is simplified with array of structures. You have a structure with student attributes as members, and then you can have array of student structures. So this is our simple student structure, which has student name and an array of 5 elements, that is marks for 5 subjects. And we have the array struct student. We can definitely initialize this array with values for all students in the class, and it works as expected. Self-referential structures contain members which are pointers to structures with the same tag. For example, consider the linked list. Here, structures are linked together in a list. The linking is done by a pointer which points to the next structure in the list. The structure in the list may look like struct element char star key struct element pointer next. The point to note is that inside struct element, there is a pointer to the struct element, which points to the next element. Linked lists are often used to implement queues, which are first in first out data structures. As another example, consider a tree. A tree is a collection of nodes starting with a root node. Each node has data fields and pointers to children nodes. The constants are that no pointer may be duplicated and no node points to the root. So a tree may look like this, which is a binary tree with a maximum of 2 children per node, and the key value of the left node is less than that of parent and the key value of the right node is greater than the parent. The structure of a node is struct node char star key, struct node pointer left, struct node pointer right. So this is another example of self-referential structures when the left and right pointers point to struct node. And we have an example program based on structures, arrays, and pointers. The program maintains an English dictionary. We can add words to the dictionary, and once we have done that, we can query the dictionary for those words and find their meaning. Conceptually, a dictionary comprises of words. A word belongs to one or more part of speech like noun, verb, adjective, etc. And for each part of speech, a word may have multiple meanings. The basic problem is data retrieval. Once the meaning of the word is stored, how do you find its meaning when the operator enters the word in the computer? We cannot do a sequential search. It will take a long time. So we use a hash function. We pass the word to the hash function as input, and the hash function gives an array index for storing the word. A good hash function gives minimum collisions. That is, it gives the same index value output for a very few cases. But there are cases when the same output comes or for multiple keys. So what do we do? For each index value, we have a linked list of meanings and keep a pointer to the linked list at the index given by the hash function. And this is our data structure. There are about 273,000 words in the English language. We choose a prime number close to this number, and 273,001 is a prime number. So we have an array of words of size 273,001. It's an array of pointers to struct word, which is the structure for a word. It has the word itself, the pronunciation, meanings, and a next pointer. The next pointer points to the next word. Remember, we use a hash function to find the array index for a word. So it is possible to have collisions, that is the same index for multiple words. In that case, all such words are chained in a linked list using the next pointer. Coming back to the word meaning pointer, it's an array of pointers, each pointer pointing to a structure with part of speech and a pointer to an array of meanings. And this is our dictionary program. The number of words, max words, is 273,001. But since we store pointers in the array and words for an index are chained in a linked list, the program can cater to more than max words, and there is no absolute limit on number of words that can be stored. Part of speech is typed of enum and can be one of noun, pronoun, verb, adjective, adverb, etc. The structure word meanings is an array of meanings for the word for a particular part of speech. Struct word is for each word, and we store the word, its pronunciation, which is the phonetic spelling, and a pointer to array of word meanings, and the next pointer. We have pointers to struct word in the main array. We initialize the words array to null, and we ask the operator to enter a word. After operator enters a word, it is checked in the dictionary. If it exists, its meaning is displayed. Otherwise, the operator is given the option to create an entry for the word in the dictionary, and the loop continues. The function meaning prints the meaning of the word. The function enter word lets the operator enter the word, its pronunciation, and make entries for different parts of speech, that is noun or verb, etc., and the associated meanings. We can compile and run the dictionary program. Unions are variables that hold values of different types and sizes at different times. For example, union uexample, int ival, double dval, char cname 15. If we define a variable of type union uexample, it can hold an integer or a double or a 15-byte character array at any time. So although you see multiple members, only one of them is alive at any time. The size of union is the size of largest member plus any padding that is required for alignment of data fields. So if we define union uexample example, we can print the size of example and it prints 16. We can initialize only the first member of a union at compile time. So we can say union uexample example is equal to 17 and the ival member is initialized to 17. Initialization of any other member at the time of definition is an error. So if we wish to use any other member of the union, we need to make an explicit initialization at runtime. How does a program know which member of the union is being used? Programs need to keep a separate variable to keep track of member being used in a union. For example, here we have a type def enum which has int, double and char as members, and a union uexample with members of the three types. So we keep a variable or eType of type enum type and keep track of the member of union example being used at runtime. Whenever we use the value of union example, we check the value of eType and process accordingly. And we come to the end of this video. You can find all this information at https://tinyurl.com/c-tutorial5. Please subscribe to my channel. Thanks very much for watching. Take care and stay safe.